Hello everyone and welcome to our channel DevOps. In today's session, we will learn about Terraform State File. So first, let's take a look at today's agenda. We will start with what is Terraform State File, why you need the state file, and how we can use the state file in AWS, and what is the difference between local and remote state files. And then we have a demo advantages of the state file, followed by the conclusion. So these are the table of contents which we are going to learn. So let's start. So what is the state file in Terraform? So the Terraform state file, typically named terraform.tfstate, is a crucial artifact that stores the current state of deployed infrastructure. It contains a snapshot of resource attributes and their relationships as defined in the Terraform configuration. This file enables Terraform to track changes, synchronize with actual infrastructure, and facilitate accurate updates or modifications when the configuration evolves. Proper management of the state file is essential for maintaining consistency and ensuring effective collaboration in infrastructure as code projects. So as you may already be familiar with Terraform, it is the infrastructure as a code tool that allows you to deploy infrastructure in your cloud. So these may include but are not limited to AWS or Microsoft Azure. For this process, Terraform uses many files, including a configuration file, usually named main.tf. In most cases, the state file provider file provides a file instance file for this portion. We will be focusing on the terraform.tf state file in this Terraform state file, and it pulls the information about the deployed infrastructure of an enterprise. Essentially, Terraform state file remembers and records what has been deployed on the cloud. And whenever it is required to make certain changes to it, infrastructure Terraform will refer to the state file to ensure proper resource management, allowing Terraform to allocate real-world resources using the configuration file, which is provided in the code format. Now let's understand the purpose of the state file. So the Terraform state file maintains the current state of managed infrastructure, enabling accurate tracking, preventing concurrent conflicts, and facilitating recovery and rollbacks in case of errors. It also stores resource metadata and output values for effective resource management. So these are the key purpose. State tracking. It keeps track of current state of managed infrastructure resources. Concurrency control. Prevent conflict by locking the state during concurrent operation. Resource metadata. Stores metadata for each resource, aiding in accurate management and update. Output values. So the record and the current values of defined outputs for querying post deployment. Recovery and rollbacks. Facilitates recovery from errors and rollbacks by storing previous infrastructure states. So how does the Terraform state work? So Terraform state works by storing a record of the resource deployed and managed by Terraform and the current configuration. So when you run the Terraform plan and Terraform apply command, it uses the content of the state file to determine the required action and to modify the infrastructure resources to bring them into the desired state that is configured in the Terraform code. The state is also used to determine if a resource needs to be created, updated, or destroyed in order to meet the desired configuration. The Terraform state can be managed locally or remotely. Local state management stores the state file on the local file system, while remote state management stores the state file in a remote data store such as Microsoft Azure Blob Storage or AWS. Remote state management provides better collaboration and security features than local state management. So Terraform state management can be divided in, into two categories: local state management and remote state management. So let's take an example. Suppose we have three servers running on our AWS and we want to change that to reach a total of 5 servers. Now, how we can achieve the desired state of having 5 servers on the cloud? To do this, user uses Terraform refers to state file to know what already exists on AWS. It sees that there are 3 servers already deployed, so Terraform adds 2 more and achieves the desired state. Now let's look at the flip side to really understand what would it look like without the state file. So let's assume that the state file is lost or deleted. Maybe for some reason Terraform can't access it now. Let's see what will happen in that case. So in this case, user again connects to a Terraform and tells it to deploy Pfizer. But this time Terraform doesn't know what has already been deployed because the information is stored in the state file, and this time Terraform can't find it. So Terraform ends up adding Pfizer to the AWS without the knowledge that 3 servers were already on the cloud, and this is not what the desired state was. And this is what being stateless means. The purpose of state file is to keep Terraform stateful in this context that will keep track of everything in your environment. So if you later need to make specific changes such as adding or deleting anything, Terraform will know what had built previously and change accordingly using the state file. In this manner, it will help Terraform to manage and allocate resource properly. So let us understand the difference between local and remote state management. In local state management, storage location is stored on the machine where Terraform is executed. On the other hand, in remote state management, it is stored in a shared bucket. Example, S3 in AWS and Microsoft Azure Service Azure Store. Local state management has no built-in concurrency control, while in remote state management, built-in concurrency control is used to prevent conflict during operation. There are limited collaboration challenging for team use in local state management, while on remote, it facilitates collaboration by providing a central and shared state. Local state management is potentially less secure as the state is on a local machine, while remote state management is used to improve the security as state is stored in a secure centralized location. In local state management, it relies on manual backups, while on the other hand, in remote state management, it is easier for backup and recovery options with versioning and history tracking. In local, it provides limited access control, relies on file permission. On the other hand, remote provides enhanced access control through packet authentication and authorization. So the command for local is Terraform apply and Terraform destroy, which may lead to local state inconsistency. While in remote, we can safely apply changes using Terraform apply without risking local inconsistency. Local state is more challenging to scale for large teams and complex infrastructure. On the other hand, remote can be used to scale well for teams and larger infrastructure due to centralized state management. For local, it is suitable for offline work without requiring remote access. And on the other hand, remote state requires network access to remote backend, limiting offline capability. Now let us understand local state management with the demo example. So local state management is the default approach employed by Terraform. Under this method, Terraform creates a local state file in the same directory as your Terraform configuration file to facilitate state administration locally. Here's how you can do it. Now let's perform practically. So we will initialize a Terraform project. So the first step is to initialize your Terraform project. So this command set up necessary plugins and backend configuration, which is Terraform init. Now we will create resource define infrastructure. Before that, we need to create the define infrastructure resource in our Terraform configuration. For example, if you want to launch an AWS EC2 instance. So what is EC2 instance? So it is a web service that provides resizable compute capacity in the cloud. allowing user to run virtual server for various applications. EC2 instances are scalable and customizable, and users pay for compute capacity they use. Now let us move on to Visual Studio. So as you can see, I have created one folder where I have named it as create first EC2 instance, where I have created a ec2.tf Terraform file. Now this is the code to create the EC2 instance, but we will see how we can create it manually, so you will better understand. So as you can see, this is the EC2 dashboard. So simple, if you have to do it manually, you need to click on launch instance. You need to type the name of the instance. For example, I have taken server 1. Now you need to select the OS. So you can select as per your choice, and each operating system has its AMI number. So AMI ID, and you need to copy this. I have selected the instance type t2.micro. You need to select key pair and simply launch instance. So as we can see, server 1 instance, first instance is created. Now this we have performed manually. Now we will try it by using Terraform. So as you can see, this is the code. So we need to open an integrated terminal to run the Terraform command. So we will type first Terraform init. So this will initialize Terraform configuration, downloading necessary plugins, and setting up the working directory for managing infrastructure as code. It is typically the first command that we need to execute while running a Terraform project. So we will type Terraform init. So the Terraform has been successfully initialized. As you can see, it is initializing the plugins. Now, let us understand the code. So the provider we have used is AWS. You can also use other provider like Microsoft Azure. Next is the profile is equal to default, means I have created key by using Amazon. Next is the resource, where I have taken resource type of AWS instance, as we need to create the instance, and I have simply taken the name my EC2. Next is the AMI number, AMI ID, which I have shown previously, as operating system have different AMI ID for each. So you need to copy the AMI ID from the AWS. Next is the instance type, which is t2.micro. Now we will simply type Terraform plan. So this Terraform plan examines the Terraform configuration and it will display the changes that will made to the infrastructure and identifies the potential issue. So as you can see, plan to want to add, which will create the AWS instance. Now let us type Terraform apply. By typing auto approve, we do not need to type yes, as it will auto approve. As you can see, AWS instance is been created. It will take some time. So as you can see, we have completed with the adding EC2 instance. Now we will check this on our console. Let us refresh this. So as you can see, the instance is created successfully. Now, if we want to modify the resource, to modify the existing resources, we need to make changes to our Terraform configuration and apply the changes again. For instance, we can add a tag to the resource created in the previous case. So we will add the name of the instance and next we will plan it. So let's check this. Save this and again clear the command. Now Terraform plan. While doing Terraform plan, so it will show that what are the changes now we are going to do. And after executing, so there, as you can see, one change. We have added the tag name. Now we will type Terraform apply. So as you can see, AWS my EC2 instance is refreshed. So enter the value yes. Before that, I have used auto approve. So now it is asking to enter a value. So we need to type yes. So this error is due to internet correction. Now we will check this if it has changed the tag name or not. So as you can see, there was no name previously, but now server 1 name is shown. So after the we enter Terraform apply command, so Terraform will identify any changes between your desired state in your configuration and what is currently stored in the local state file and make any necessary update. Now, if we want to delete the resource and clean, so we simply need to type first, we will clear this. We need to simply type Terraform destroy command. After doing so, our instance will be terminated. After you create an instance, it is necessary to destroy it. Type yes. As you can see, AWS instance is destroyed. It is still destroying. So what are the challenges with the local state management? So limited collaboration. Local state files are tied to individual machines, making it more difficult for teams to collaborate effectively. There is a risk of data loss in local state files, as if a machine crashes or a state file is accidentally deleted. Concurrency issues. Within teams, multiple members may attempt to implement changes simultaneously, leading to conflicts in configuration. So we will take an example. But before that, we will check, yes, we have destroyed the instance successfully. Now we will check this on any EC2 dash. So as you can see, there are no instances running in this region. So let's take an example for what are the challenges with local state management. So to understand things much better, suppose a manager tells history of two developers to make changes to the existing infrastructure. So there are two servers already deployed on AWS, but the business requirement is to have a total of 5 servers. So servers need to be added and manager tells this team of two developers to reach the business requirement. For this case, we will assume the both the developers have taken initiative of updating the infrastructure. So let's see how this plays out the first developer. As he will add the 3 servers, meanwhile the other developer is also the same, as both developers are connecting with Terraform to update AWS, which is currently has only 2 servers. So the first developer ends up adding 3 servers to the AWS, resulting in the 5 servers. But the other developer also does the same thing by adding 3 servers. This results in total of 8 servers on the AWS, whereas the requirement was to only have 5 server problem, which is solved using remote state file storage and blocking mechanism. So it will avoid these issues. So we will understand this even more moving forward to remote state. As a result, in having a total of 8 instances running, this is why the state files when we use locally can result in severe issues. Now let us move on to remote state management. So remote state management is more robust approach suitable for team environments and production use cases. In this method, the Terraform state file is stored remotely in a shared location that all team members can access. Common choices for remote state storage include Amazon S3, Azure Blob Storage, and Terraform Cloud. So what is an Amazon S3? So Amazon S3 is a simple storage service, which is a scalable object storage service in the cloud, designed for secure and durable storage of any type of data. It provides easy-to-use management features and pay-as-you-go pricing model. Now we will set up a remote state manager. So we will start with initializing a project, then configure the remote state backend. So in our Terraform configuration, we will take main.tf file and specify the backend configuration to use the remote state. For example, using the Amazon S3 as remote state backend. So let's try this. So first, I have created a folder of state2s3, and next I have created one file called as main.tf in this folder. Now we will open an integrated terminal to execute the Terraform command. So as you can see, provider name is AWS. We can use Microsoft Azure as well. And the resource, first we are going to create with AWS instance. This is the AMID of operating system. And this is the instance type, which we have selected t2.micro. And tag name, as we have previously named the EC2 instance with server 1. Now we are naming it with EC2 instance with remote state. And next is the Terraform. So it will begin the configuration for Terraform settings. And backend, we are using simple storage S3 to specify the backend configuration for storing the Terraform state file in an S3 bucket. So bucket, it specifies the name of the S3 bucket where the Terraform state file will be stored. And this is the key, which is the path of the state file where the Terraform state file will be stored. And this is the region we are currently. So we are currently using region North California. And as you can see, this is the reference name for North California, which is US West 1. Next, this is the key. Now, let us create a bucket. So we will create a bucket by clicking on creating a bucket. Type here the bucket name, which is my AWS storage bucket 1. Select the region. Enable the versioning and simply click on create bucket. So as we can see, the bucket has been created successfully. Here you can see the bucket name. And after clicking on this, you can see here we have to store our Terraform state file. Now we will run the Terraform init command for initializing all the plugins and dependencies. Run the Terraform init. Copy this Terraform init migrate state. So as you can see, it is initializing the backend and backend configuration has been changed. First, we have created an instance which we have named EC2 instance with remote state, and then we will store our terraform.tf state file. Next, we will apply Terraform auto approve. So as you can see, AWS instance EC2 instance is creating. So as we have discussed the previous example, the previous issues are resolved by storing the state files on the cloud. For this, we will use some AWS feature. So we have already created a S3 bucket which will be used for storing the state file data. And we can also resolve previous issue by enabling the locking mechanism by using DynamoDB that will store the metadata to add locking feature that will ensure only one person can make changes to the AWS at a time. And after this, we just need to configure Terraform. After doing this changes, the situation will play out differently. So as you can see, apply is completed and resources are being added. Now we will check this. So I have, as you can see, I have created one folder dot name S3, and under this folder, we have successfully created Terraform.tf state file. And we will refresh the instance. So as you can see, EC2 instance is also being created. So Terraform will store the state remotely in specified bucket, making it accessible to team members. So now let's take the previous example. Now let's understand we still have two developers wanting to make some changes. So first developer connects with the remote state file stored in the S3. So the developer then goes ahead and make the changes to infrastructure by acquiring straight log using DynamoDB. After this Terraform apply changes to the infrastructure during the entire time, the other developer can't make any changes to the infrastructure because the first developer is in still process of making changes. Hence the developer with the log gets the right to change the infrastructure and other cannot make the changes during the same time. So what are the benefits of remote state management? So remote state management offers several advantages. Improve collaboration. All team members can now access and update the same state file without manually sharing and synchronizing the state file. It will increase the security. So Remote state storage solutions often have a built-in security features, including access control mechanism. Better data protection. So cloud-based remote state solutions typically offer data backups and versioning to protect state data from accidental deletion or corruption. So effectively managing state files in Terraform is crucial for maintaining infrastructure integrity, ensuring collaboration, and enabling seamless update, ultimately enhancing the efficiency of infrastructure as code workflow. So for reference, you can visit the Terraform registry where you can select a provider as AWS and you can get the code for AWS instance as well as for S3 bucket. So if you have any queries, please contact us. Thank you for watching. If you enjoyed this video, don't forget to like, subscribe and hit the bell icon for more content. Feel free to leave your thoughts or suggestions in the comments below. See you in the next video. Thank you.